This is the only class of the chapter applications of calculus in commerce and economics, that is the first chapter of section C. And we are going to try finish off this chapter in this class itself because there's not much to discuss, and thanks to the reduced syllabus we have a lot of things which we are not going to discuss anyway. So let us first see what are the things that which we are going to discuss in this class. So we are going to talk a little bit about cost, demand, revenue and profit functions, and then break-even points, marginal costs and revenues, and finally the increasing and decreasing functions related to the cost, cost and revenue. Now obviously there were maxima, minima as well, which was part of the discussion, but which has been removed from the syllabus, so we are not going to discuss that part. Now let us begin with the idea. Now those who are commerce student, you people have already done this previously, so I think for you this is nothing new, so it will be very easy for you to solve it. But for the science students who are going to deal with this for the first time, for you people, so the thing is that this is related to commerce, so if you don't have the idea of the commercial terms, then it will be a little bit difficult. So let us first discuss all those terms. Now cost function. Now the idea of cost function is that whenever you are producing something, producing an item, or in technical terms we call it commodity. So whenever we are producing some sort of commodities in factories, in wherever we are doing it, so, and also storing them, so all the expenses that are related to the production, so it can be transportation, it can be buying the raw materials, everything altogether, the labor charges while producing it, or the factory time, the machine times, everything, all the things that are, all the factors that are related to the production, that the cost incurred to do all these things, that is called the total cost, that is called the cost function. And to simplify everything down, we are considering that this cost function is related, or it is based on the number of units that we produce. Obviously, because if we are producing lesser number of units, then it will take us lesser amount of time, it will take us lesser manpower, it will take us lesser machine time, so also lesser raw material. So obviously the whole cost of production depends completely on the number of units of commodities that we produce. Then each and every cost has got two heads. One is the fixed cost and the variable cost. Now fixed cost is basically the cost which is invariable to the amount of or the number of units or the number of goods that we are producing, and the variable cost which depends on the number of units. So the fixed cost is mostly the warehouse charges, maybe the overhead charges that which you require to transport the goods, and the variable charges can be the raw materials, the manpower, etc., which are dependent on the product or the number of units, also the machine time, and so on. Now the average cost is basically the total cost divided by the number of units. And also the average cost has got two heads, that is the average fixed cost and the average variable cost. Then let us take up a small problem to understand the whole idea. The question is, For manufacturing a certain item, the fixed cost is rupees 6500 and the cost of producing each unit is rupees 12.50. What is the cost function? Draw a graph clearly indicating the total cost, the total fixed cost and the total variable cost. What is the total cost of producing 75 items? And what is the average cost of producing 400 items? So let us consider that the number of units that which is to be produced, Bx. So the total fixed cost is given to be 6500, the total variable cost which is 12.5 per unit of item, so therefore it is 12.5x, and therefore the total cost is 6500 plus 12.5x. Now what we need to do, we need to plot all these points on a graph. Now the total fixed cost is 6500, so it will be a parallel line to x-axis passing through 6500. 12.5x will be a line passing through origin, and the total cost, that will be a line. If you just see it clearly here, see this. This is the total fixed cost, which is a parallel line to x-axis. The total variable cost, it is starting from origin and it is going upwards, and the total cost will start from the 6500 mark and it will go upwards. So this is how the graph looks like. So it's very simple to draw. Now next is, what is the total cost of producing 75 items? So just put 75 in place of x in the total cost and calculate. So this is your answer. And then what is the average cost for producing 400 items? Now obviously the average cost function is going to be 6500 by x plus 12.5. Now put 400 in place of x. So therefore the average cost of producing 400 item is rupees 28.75. Right? Next, let us understand few more ideas. Now, demand function. Now this is something which is very important. We need to understand what is the idea of demand function. The demand function is basically the relationship between the price per unit of items sold and the unit of items. Now obviously after the production is done, when I'm trying to sell it in the market, now depending on the demand of that particular product in the market, the price of the item is decided, the price per unit item is decided. Now basically, generally what happens is that if the demand is high, then the price per item will be low, and if the demand is less, then the price per item will be more. But we have to consider the different situation or the different scenarios here. What is the scenario? Now if there is only one particular company producing the item and there is no other company in competition in the market, then it really does not depend on the demand that what will be the price of the item, because as it is the sole company producing, they know that doesn't matter what, it will be their product which is going to get sold, and therefore they can go on manipulating the price per unit according to their wish. Right? Now if it is a competitive market, if the market is competitive enough that there are several companies producing the similar item, then definitely the cost per unit of the item is not going to be decided by the companies themselves, but they have to follow the market trend to decide the price per unit. Right? So in to be a little bit simplified, we can also say that whenever I am in a competitive based market, it is not in the hand of the producer to decide what the price per unit is going to be, and therefore we can consider that the price per unit is going to be constant in the sense as it is not a factor based on the company which is producing the item. Now, the revenue. Now, what is the revenue? Revenue is basically whatever amount of money you are getting after selling the particular item. So whatever is the total amount you are getting, that is your total revenue, and it is basically the price per unit multiplied by the number of units sold. Then average revenue is the total revenue received divided by the number of units sold, and if you see that it is basically nothing but it is the price per unit item. Then profit. What is profit? Obviously, whatever is this, now you have done it in your junior classes in a very simplified version. We used to call it as the selling price and the cost price. So definitely the selling price minus the cost price gives you the profit. Now here also we are going to follow the same idea. So it is the total revenue minus the total cost gives you the profit. Now obviously the total revenue has to be more than that of the total cost, then only we can have a profit. Now if we don't have the total revenue more than the total cost but it is coming out to be exactly equal, so that point is called the break-even point. So the number of items sold in such an order that the total revenue is exactly equal to the total cost, that point is called the break-even point, or the point where there is no profit or no loss. It is the point where the profit is actually zero. Now also break-even point can be described as the point where the number of items sold in order to cover up the total cost of production. So that also one of the way to describe the break-even point. Next, let us take another example. Example number 2. A publishing house finds that the cost directly attributed to each book is rupees 30 and the fixed cost is rupees 15,000. If each book can be sold for rupees 45, then determine the cost function, the revenue function, and the break-even point. So the cost function will be the fixed cost plus the variable cost. So fixed cost is 15,000, variable cost is rupees 30 per unit. So that is 15,000 plus 30x. And the revenue function will be rupees 45, that is the price per unit, and into the number of items sold, so that is 45x. And so for the break-even point, the revenue must be equal to the cost, the total revenue must be equal to the total cost, and if we solve, we get the break-even point as 1000. So you need to sell 1000 items in order to cover up the cost. That's it. Next, number 3. The question is, the price of selling 1 unit of product when X units are demanded is given by P equals to 4000 minus 2x. The fixed cost of the product are 20,000 and 1484 per unit. Find the level of sales at which the company expects to cover its costs. So it is basically asking you to find the break-even point. So now cost function is this 20,000 plus 1484x, and then what is the revenue? Revenue is basically px, that is 4000x minus 2x square. So at break-even point both will be equal, so just go on solving it. If you solve it, you get x as 8, or 1250. Now obviously we are going to consider the lower of it, so therefore if you can sell at least 8 items, then definitely you can cover up the cost. So the minimum number of items that we need to sell to cover up the cost is 8. Obviously if you have sold 1250 items also, you would have covered up the cost, but definitely whenever we are talking about covering up the cost, we are always going to talk about the minimum number of items that we need to sell to cover up the cost. So therefore if we sell 8 items, we can cover up the cost. Next, number 4, the demand X of a commodity in terms of price P is given by this. The average cost is rupees 20 per unit. Find in terms of P the cost function, the revenue function, the profit function, the price and level of output at which profit is 0. So therefore, what is the average cost given? That is rupees 20 per unit, so therefore it is 20x. And then what is the cost function? It will be I'm sorry, I just made a mistake. Average cost is given rupees 20 per unit, so therefore rupees 20 is the cost, average cost. So here I have just made a small mistake, so please be careful, there won't be any x. Now the cost function is 20x, that is the average cost multiplied by the number of units. Now as we are told to write it in terms of P, it will be 20 into 1 by 9 into 245 minus 7p, so that is our total cost. Then what is the revenue? Revenue is nothing but P into X, so revenue will be 1 by 9 into 245p minus 7p square. Mind you, you are writing the answer in terms of P, not in terms of X. Then what is the profit function? Profit function will be Rx minus Cx. So if you just do the calculation, this is our profit function. And the price and the level of output at which profit is 0. So basically we are trying to find out the break-even point. So if we solve it, we can see that this comes out to be p square minus 55p plus 700 equals to 0, and that is p is equals to 35 or 20. Now obviously p can't be 35. If you take p as 35, then x becomes 0, which is not the case. Obviously you can't sell anything to have no profit, so therefore you must sell something to get some profit. So therefore we have to consider p as 20. So therefore if p is 20, then x is 35 by 3. So therefore 35 by 3, or you can write it as 105 by 9, so whatever is it is. So therefore this is your answer. Now obviously this is a very hypothetical case. Now you can't have number of units to be in fraction, the number of units has to be in integer. What this means is that 35 by 3 is roughly around 12. It is something less than 12. So that means what? To at least get some profit, you need to sell at least 12 items, or you at least need to sell 12 items to get some profit. This is 20. Please be careful. Okay. Now number 5, or we have another part. So here in this part we talk about the marginal cost and marginal revenue. Now what is marginal cost? It is nothing but it is the derivative with terms of the number of unit of the cost function, that is your marginal cost. And marginal average cost, you can see it is average cost is C by X. So if you just do the derivative with terms of X, you get average marginal average cost as 1 by x times the marginal cost minus the average cost. Then marginal revenue, it is once again that is ddx of px. Now if you have a competitive environment, as we discussed, if the in competitive environment the price per unit is not decided by the company, so it is constant, and hence the marginal revenue is same as the price per unit or the average revenue. But in case of a monopolistic environment, we have P, that is the price per unit, which is depending on the number of units sold, which is a function of x. So therefore the marginal revenue becomes P plus x dp dx. Now dp dx, that is the derivative of the price per unit with respect to x, is always negative. Why? Because the number of unit and the price per unit, they are inversely proportional. So as the price increases, the demand decreases. As the demand increases, price decreases. So therefore they are inversely proportional, and hence dp dx will be always negative, and therefore the marginal revenue will be always less than the price per unit. Let us move to next example. Now example number 5, we have given the total cost function for x units of a commodity as cx is equals to x cubed by 3 plus 3x square minus 16x plus 2, find the marginal cost function and the average cost function. So simple enough, what is the marginal cost? It will be just the derivative of the cost function. So basically this is your marginal cost, and the average cost function is nothing but it is the total cost divided by the number of units, that is x. So therefore average cost is this. Simple problem. Next, number 6. If the total cost is given x cube minus 24x square plus 600x, find the marginal cost and the average cost, and also calculate the range where AC falls. So let us come to the second part later. First, let us find out what is the marginal cost and average cost. So marginal cost is basically the derivative, and the average cost is divided by x. Now for the second part, calculate the range where AC falls. Now this means I have to calculate where the average cost is decreasing. Falls means decreasing. So therefore, if you remember the application of derivative chapter which we have done previously, how to find the increasing or decreasing of a function. So we are trying to find where this function is increasing or decreasing. How to do that? So first we are going to find the derivative of this. Then we are going to find all those points where the derivative is 0. Then we are going to draw the number line, and we are going to check on which side it is giving you positive and which side it is giving you negative. The side where it is giving you negative is the decreasing side. The side where it is giving you positive is the increasing side. So we are talking about decreasing. So let us see how to deal with this. So let us first do the derivative of average cost. So if I do the derivative of average cost and put it equals to 0, then x is equals to 12. X is coming out to be 12. Now let us draw the number line. Now if I draw the number line, now the only thing is that I am going to start from 0. I am not going to start from infinity. Why? Minus infinity, because we are talking about real world problem. We are talking about the commodities. So here number of commodities can't be negative, so therefore we have to start from 0. Now here there is 12. Now put any value between 0 and 12 and put any value after 12. So if you put any value between 0 and 12 and put it here in the derivative, I see that it is giving me a negative value, and beyond 12 it is giving me a positive value. So that means the average cost falls if it is within this range, and the average cost increases if it is beyond this range. So therefore I can say the average cost falls when x is between 0 to 12, that is when the number of units produced is between 0 to 12. Number 7. The total revenue in rupees received from the sales of x unit of a product is given by Rx is equals to 300x minus x square by 5. Find the average revenue, the marginal revenue, and the total revenue when the marginal revenue is 0. So let us start off with the average revenue. Average revenue will be the total revenue divided by x. So therefore this is the average revenue, and the marginal revenue is this derivative of the total revenue. Now the third part is find the total revenue when the marginal revenue is 0. So let us put marginal revenue as 0 and find the value of x. The value of x is 750. So now put 750 in place of x in Rx, and hence the total revenue is rupees 1,12,500. Number 8. The marginal cost of manufacturing x units of product is given by this. If the fixed cost is rupees 1250, find the total cost and the average cost. Now, till now we did the thing that the total cost given and we found out the marginal cost. Now, how to find the marginal cost? Marginal cost is basically the derivative of total cost, right? If we do the derivative of total cost, then we get the marginal cost. So therefore we can write that the total cost will be nothing but it is the integration of the marginal cost. If we integrate the marginal cost, then we get the total cost. So therefore, if this is your marginal cost given, then the total cost can be written as integration of the marginal cost dx. Do the integration, simple integration. So once you have done the integration, this is our marginal cost, the total cost. Now see here, this plus c is the integrating constant. Now we need to find the value of the integrating constant. It is told that the fixed cost is 1250. Now if the fixed cost is 1250, that means it is the constant part of the total cost. And here you can see that c is the only constant that you have in the total cost. So therefore I can directly say that c is the fixed cost, that small c, and hence our total cost is x cubed by 3 minus 75x square plus 750x plus 1250. Fine. And then to find the average cost, just divide it by x. If I divide it by x, then it is x square by 3 minus 75x plus 750 plus 1250 by x. Simple enough. Next, number 9. Last problem. The marginal revenue of selling x units of commodity is given by MR is equals to 20 to the power x by 10 into 1 plus x by 10. If the revenue obtained on selling 10 units of commodity is rupees 200e, find the revenue function. Now, seems a little bit far-fetched because in general we don't have this kind of function, but believe me, in calculation there can be so many different factors coming in, so you can have a marginal revenue function looking something like this. Now to find the total revenue, I have to integrate the marginal revenue with respect to x. So this is what the integration looks like. Now let us do one substitution. The substitution being, let us consider x by 10 as z, then dx becomes 10 dz. Now putting everything back into the integration, it becomes 200 into integration e to the power z into 1 plus z dz. Now this is a by parts. Do the by parts integration. This is what you get, 20x e to the power x by 10 plus c. Now it is told that selling 10 units gives you rupees 200 E. So therefore, putting 10 in place of x, I can see that 200 E is equals to 200 E plus C. So therefore the value of C is 0. I am putting x equals to 10 here, and if I put x equals to 10 here, I am getting 200 E plus C. But it is also told that after selling 10 commodities, 10 units of the commodity, I am getting rupees 200 E as the total revenue. So this must be equals to 200 E. So this becoming equal to 200 E means the value of C is 0. So therefore the total revenue is 20x e to the power x by 10, and that's your answer. So that's it. This is our only class on the chapter application of calculus in commerce and economics. Please ensure you get your doubts clarified if you have any. Thank you.